p.m. at night and run till early morning. So uh, thank you for helping us and presenting today.
Sure. Sure. So thank you.
Thank you. Okay, this is the interim uh, for ITF. It looks like I missed another thing for ITF 125. We're trying to hold these interims to get discussions. One of the things we want to do with in person or uh, uh, the in person mixture of online sessions at ITF is to make sure we've worked on discussions before, and if we can, to ask for adoption or early allocation as soon as possible. We are in a situation where you need to read the note well. All of our interims and meetings are held in accordance to the note well. It expects you to behave in a professional manner with an extended respect and courtesy to your colleagues. It also expects, if you know of any IPR, you realize that the IPR is governed with the rules from RFC 5378 and RFC 8179. Additional things about the standards process, please read the interesting information about our standards. Okay, with that formality, one of the things IDR status has been changing. This is a status moment. Um, the chairs have started using it in their daily work. So you're going to find status on the web, but we've been using for our daily work a GitHub. So please read it there. That'll be probably your most updated one. I am trying to keep the wiki updated for a while, but we'll see if people can use the click link into the GitHub. You'll find it's fairly done. There are current status, there are action items, and we're also putting drafts with lots of discussion in. So if in the middle of going for working group last call, your draft has been transferred to the GitHub, it's because we're trying to track specific discussions. Another thing we're trying to track is we're trying to track area director actions relating to the IDR. So Gaten has some rechartering discussions. Please take a look at it there. Add your comments. You can add issues to the wiki. We're also tracking in the main status the IDR documents at the RFC editor and the ISG, the working group last calls completed but waited for Shepherd Upright, and the working last calls in process and pending. We're also tracking the adoptions in process and pending. Now, some of these may go out to another field to make it more readable. We owe Jeff and thanks for doing that in the middle of 2025 while I was on extended leave. There, now, our IDR work, if you noticed from 124, has started to work in groups, which is good news for you in that we're treating the queues as queues per area. Core BGP, BGP flow spec, BGP LS, BGP segment routing, that includes BGP segment routing TE, and BGP, that's from RFC 1930 and such, and BGP SR, which is from the BGP prefix SID attribute. So diving into this, where are we with the last call status? Past last call is the BGP model, the SD-WAN, the BGP CT SRv6, and the derived community. You'll find that we're working through either revisions to those documents or Shepherd. We're in the midst of working group last call for 4 things: draft ITF, IDR, NHC. I will close that with consensus, but I'm missing Caridi's IPR. I have, we're draft ITFR SR policy sedge list has had IPR working group last call, but we should start the actual working group last call after I have sent them a few more reviews. By the way, when you go into working group last call, the IDR chairs are being much more proactive. Each chair is reviewing a draft going into working group last call. We have draft ITF IDR flow spec redirect and draft ITF IDR TS flow spec SR policy, and that's because it's changed from informational to post to proposed standard. Okay. The core BGP, we sometimes are waiting for working group last call on a second implementation, and some of them we're waiting for review, and some of them because sometimes when the chair gets to do lots and lots of things, their drafts sit behind. So those are the core BGP status. The early allocation, as Srihari has been kind enough, we're going to start a 2-week working group last call on early allocation. He's going to present, and then I'll start the working group last call for the early allocation. We have these other drafts that we're working hard to try to get a chair review on. You'll notice that we're carrying quite a lot of reviews. And so today we're organizing things by group. We have the BGP core for dynamic capability, RPI, BGP origin that shares with CyberOps, and then 3 BGP LS, and then for specification, and then SR. So with that, I think I'm 2 minutes over. We're going to go right into mingling with the BGP origin attestation. And do you want me to run the slides, or can I hand you these slides?
You can start the slide share and then delegate it to them.
Okay. I am going to start the slide share and delegate it to him. We have confirm it, and then where is the delegation function, Jeff?
Better question is, I'm not seeing Minching on the participants. Minching, are you here? If so, please start your microphone share.
I don't see him either. Let's go on to the next presentation. We'll try to pick this one up. Okay, let me grab another slide. Share. I believe the next one is mine, but I'm not seeing it up there either. Hold on, let me see if I've got it. Just a minute, Jeff. Our next presentation is status for the BGP LS, and I'm looking for it on the link. Just a minute. Well, fortunately, it's my presentation, so give me a moment. I will upload the slide. The next presenter can.
The next presentation after the status was going to be Shinchin.
Okay, I am looking. There it is. Give me a second. I will upload the slide set.
Hi, so I think Mingqing has joined the meeting now.
Okay, why don't we go to Minjing then, and let me then grab the slides. I'll try another one. Hold on. Gee, will you also make sure the BGP LS presentation on BGP status is up there for afterward? Okay, I'm going to delegate the slide if I remember right. I'm not seeing Ming Ching.
Hi, Susan. Can you hear me?
Yes, I can hear you.
Sure. Good.
Hi, Sue.
There we go.
Okay,
I've got the slide control to you. You're good to go.
You have a slide control, right? Okay.
You should have the slide control. Good.
Okay.
Thank you.
Can. Yeah. Thank you. So should we start, or wait the right time? I mean, I was told that about 30.
No, please go ahead.
Go ahead. Okay. Great. Thank you. Thank you, everybody. Good morning.
Do you have
good afternoon.
slide control?
Yes, I just tried. It seems like
There you
yeah,
go.
I have it. Okay. There we go. Thank you for everybody. And this is Mingqing from Zhengguancun Laboratory. Actually, I used for work for Huawei for very, very long time. And I'm very glad to present a new idea about the BGP. Actually,
I am not
archetype.
hearing you.
Sorry,
Sue, I am able to hear him.
can you hear me?
Minjing, we can hear you. If other people could please chime into the chat to verify that you could also hear Minjing, that'd be good.
I can hear Sriram.
Thank you,
Hi,
Shriram.
Sriram.
We're seeing many people. So Sue seems to be having issues with her microphone. Minjing, please go ahead and get started.
So I can go ahead.
Yes.
Okay, sure. This is about the RPI-based BGP OA or origin attestation. So I'd like to. This is 4 parts of this slides, and I'm going to focus on these first 2 parts, the background and the solution overview, because of the limited time. So why we want to do this, proposal? Because my observation is currently RPI consistent is good to help BGP to verify whether the originating information is correct. But fundamentally, there's something lay behind that make the RPI, actionable, difficulty. One is that the amount of invalid states. As you guys may know that NIST RPI monitor always reporting that thousands of routes are invalid normally, and according the studies that most of them, majority of them is kind of a transit false positive caused by unsynchronization between the RPI managed plane and router counter plane. And the other issue is that RPI itself to help to routing system, but it itself could be wrong, and sometimes it's not is outdated. So these two kind of thing that will confuse with operators with true positive, true hijack. So this will bring another issue, that is when we do ROV, some operators they, because some wrong decision is needed by this uh, false information, so there will be got overhead of operational. So this is to make them hesitate to uh, deploy ROV, or enable the drop invalid messages. So this is the some kind of background of the key is, again, key is the one thing is the unsynchronization between the control plane and the manage plane of RPKI. Even worse is that the snapshot between router, RPKI snapshot between router is not sync up because the time difference for for download. So this is background, and then what we can we do? The general idea is come from how we can make things synchronized together. This is all we're trying to we're thinking and to get something done with this. So the core idea is that we want to do the pre-validation in the origin point, and then we'll test the downstream areas that what we have validated. And by doing this, we not only we can make the control plane and the data plane synchronized, but also we can, based on the same attested information from the original router, that the downstream router can be in the same page too. So by this tool will help a lot to address the problem we list the previous page. So here we go. This is how we solve the core problems. So by pre-validation and attestation, we can enable the downstream router to identify and bypass the issue raised by the synchronization delays. And also by isolate the translate the false positive, isolate the misconfiguration, and then we, with the help of the original router, we can quickly identify the true hijack. So that would be make the downstream AS deploy the ROV with more confidence. Okay. So here's some details about the solution. I'm not going for very details. Basically, this kind of BGP OA attribute extension is quite similar with BGP seg, but with no required that we do hop by hop to sign and do verification and etc. The attribute is kind of optional but transitive kind of attributes. And the key information, of course, is about who is signing this message and what they are trying to attest, like the prefix and the validation, pre-validation states, etc. Okay, and the base idea is similar to BGP-SEG, how we do the attestation. For originating router, there are two major procedures. One is that when we do a route announcement, we must do the validation against the local local RPKI VRP data. Based on the validation result, if the result is invalid, we should hold the announcement and send alert to the operational guy and make them fix either the RPKI error or the route announcement configuration error. Okay, and then if we passed, then we will create the BGP OA attribute to advertise the updates with the BGP OA attributes. And the other procedure is about what if we have a raw cache updates. In this case, we were going to do revalidate the origin rows and do the afterwards doing the similar job as the previous one. So this is originating router, downstream router. It basically make a decision by the dual signal, that is a local ROV result and also the attested result from the originating router. So this is some kind of a combination, and what kind of conclusion we made. The most important part, maybe the valid part, is that we can avoid likely transient false positive, by the attestation, and then later we can do some kind of recheck whether it's correct. And the other thing is that we should allow the partial deployment of originating AS, which means not all the ASBR are required to enable the BGP OA. So we design a collective knowledge about the attested origin prefix list to accept both the updates with or without the BGP OA attributes. So here's some consideration. I'm not going one by one, just I just said we should backward compatible to, and then security mode. And what I want to share is that actually there's some kind of argue about this proposal in CyberOps group. I'm not going very detailed about this argument. Basically, some say ERP, egress RV, which means RVC 8893, right? Already it addressed the transient false positive. Indeed, I think the egress RV can fix the transient false positive in the point where the egress RV deployed. But compared to we fixed it at the very start point, which means it's the original point, that can make some kind of one is latency. You drop first and then renounce, and in not synchronize with other point. I mean, other point in the routing system may not deploy the egress RV, or even not RV, or some just ingress RV. So we cannot on the same page and at the same time. So the global host system will then may suffer, misleading routing decision or route ordination. And again, in summary, that this proposal is kind of egress ROV plus BGP-SEC, but with some kind of simplification and focus, to focus on the how we can do more job on the originating point to make things correct, and then spread the synchronized information to allow the downstream router to make decision with the same page. So that's all from me, and and this is okay. Forget, and then we may need to do something if it is good for our working group, be related to INR and whatever. Okay, that's all for me. And any questions?
Microphone queue is open. We have a few minutes for questions. So while we're waiting to see if anybody else adds themselves to the queue, thank you for the presentation. I'm going to encourage that discussion of this continue both on IDR and also please copy the CIDR Ops mailing list. There's obviously some opinions about the proposal here. Joel, you have the queue.
Thank you. Listening to the presentation and watching the discussion on the lists about this proposal, there seem to be two parts, and I want to make sure I understand the relationship. The pre-validation you described looks like if you weren't doing the remote attestation, would be a purely local implementation matter. May even be a good idea. Before you advertise something, make sure your ROVs are consistent with your advertisements. But it's purely a local matter, doesn't require standardization.
Yes.
It's the is that correct?
Yes. In some sense, it's correct that if we just do pre-validation, that could be best current practice. We want everybody is following. But other thing is that we don't know which one did do this thing. So which means we still need the information to downstream router. So whether you did the pre-validation, we need to know for downstream router.
Okay, so assuming you're dealing with configuration errors and assuming this is being generated automatically, if I've understood right, if there's actually an inconsistency, the advertisement should never get out. So what is the value in putting an extra cryptographic computation in and putting an extra advertisement in and flooding that across the domain, since if they're inconsistent, it should never leave the origin. And if somebody as an origin chooses not to implement this, and so they get dropped because they have inconsistency, isn't that their problem?
Yes. Let's back to this page. You got a very good question. So sometimes, even we got the BGP OA attributes, but sometimes the message is with the attributes, but some are not. So what if how we treat this kind of thing, right? Am I correct with your question?
No, what I was asking was, what is the value of advertising it? Because if somebody is doing the pre-validation, then they will never advertise inconsistencies, and tagging it so that somebody else could tell if they advertised inconsistency does nothing. If somebody is not doing the checking, well, if they misconfigure, they get blocked. That gives them an incentive to fix it. Whereas you seem to be trying to get people to accept things when the origin has misconfiguration, and that seems to be fundamentally at variance with the goal of the whole operation.
Yeah, the benefit is like that we prepare more or prepare better with first mover. I mean, if you attest your pre-validation result, and the downstream know this, downstream will get more confident to move your message correct. That is benefit.
Okay, I'll leave it there.
Yeah, yes. And also avoid transient false positive misjudgment about in the downstream router. Yeah.
Yes, this will be a conversation that's good to continue on the mailing list. We are unfortunately out of time for your presentation.
Thank you.
Thank you for the presentation. Sue, did you want to take over? Okay, Sue has been having some issues with her microphone.
Hi, I'm back. Thank you.
Okay,
I
we can now
came.
hear you.
Good. I'm going to share the slides just a moment. I believe G has uploaded the last slide set. I'm not seeing them. Okay. That is my fault. I missed. There it is, status for BGPLS. Thank you, G, for fixing that. It is, G got confused because it says BGP tunnel attribute. Excuse me, I was tired last night, maybe too much Super Bowl fun. So the next set of slides are BGPLS. So one thing I've decided we do in this is to have the status not be all up front, except for the working group last call, but the status work through as we have talks. Again, BGPLS is a separate section in the main status, and there are links to the working group last calls and the adoption. For BGPLS, there's status that we update about monthly, and then there are Shepherd reviews. I'm trying to do a Shepherd review for BGPLS and BGPSR and FlowSpec once per ITF. So if you have 3 ITFs, you will have 3, which is what I just said. Early allocation, if you're looking for that for your BGPLS, is afterward. We will start to use BGPDir to work with working groups with BGP LS drafts that are in IDR working group. Thank you, Caton, for starting that off. And prior to the working group last call, we're doing English language reviews, IANA reviews, and early routing DIR reviews, as well as IDR chair reviews. So if you've got a BGPLS, be aware that these things are happening. This is more taking a proactive stance by the working group chairs to make sure we give you as much review. It's was a little painful in 2004, 2005 to do all these reviews at the end, a little bit all the time. So what do we have? We have 10 working group documents. 5 are actively in working group last call, and our current focus is draft ITF, IDR, BGPLS, inter AS topology external. That's the one we're reviewing. There are 12 adoption requests, 2 waiting for the chair review, and 3 pending Shepherd reviews. So we're trying to keep the flow. The pending working group last documents are shown here. BGPLS, SR, NR policy, path segment, IS flood. Notice when you see in the status awaiting such and such and you're an author, that means you need to go and fix things that were mentioned in your Shepherd's review. If you see holding for an SR draft resolution, it means we'll do the BGPLS draft for a particular function like NRP or path segment after the SR draft is due. And today we have 1 draft that's in the adoption queue and 2 that are not. And with that, we will start with the BGP with the next presenter. Our next presenter is Qingxi Yi, and if you're ready, I'll load your draft.
Hello?
Give me a moment to load your draft, and then I will. Do you see the draft on the screen?
Yes.
You now have control of the slides.
Okay. I can control. Okay. Hello, everyone. I'm Xinxin from China Income, and I'm here to present the draft about distribution of servers metadata in HDLs. And we presented this draft in the CATS at the last meeting, and the CATS chairs and experts confirmed that the requirement is clear. So the requirement is come from the CATS work. CATS. The CATS framework draft has completed last call, and it identifies 3 deployment models, including the distributed, centralized, and hybrid. So for the distributed model and the centralized model and the hybrid model. For the centralized and hybrid model deployment, compute nodes need to report computing metrics to the controllers or the other CPS locations. So our draft addressed exactly this requirement to use the BitPL's extension to collect service metadata. Why we do need to this work in the draft about the 5G edge service metadata already defines BGP extension for the distributing service routing with computing related metrics. But there is a gap. The router connected to the site can connect this information, but controllers also need this information to calculate the best. So our solution is to extend BGPLs to carry service metadata. So why we use the BGPLs? We think there are 3 reasons. First, it is the native support for the network topology collection. That's what BGPLs was designed for. And second, the Metro Protocol Foundation, FC and 77 and 7715.2, and provide a solid framework. And also it's a natural extensibility. New TLVs can easily carry computing metrics. So we do the extension about consist of the 4 parts. First is the prefix NLRI, and following the BGPL's RFC 7752. A service is identified by a prefix using the IP-rich information TLV to carry the service prefix. And the second is the metadata path attribute TLV. This is our new TLV. And we reuse the metadata format defined in the 5G edge service metadata draft. And it contains multiple sub-TLV, each carrying a specific edge service metadata matrix, such as the site prefers, site physical available index, and so on. So the set is we extend the prefix seed attribute TLV. Following the RFC 1918.5. In some scenarios, multiple sites connect to the same egress router through different interfaces. So we need SRMPS or SRv6 channels to connect steer traffic. For example, SRv6 endpoint behaves can be encoded for each site, allowing the egress router to steer traffic to the corresponding site. So under the fourth, we extend the color attributed TLV used to indicate the service level. Different sites may have different service capability levels, so which the controller considers when the calculating path to egress router. So is the metadata path attribute about the TLV is the format about the new TLV, and we reused the metadata format about the in the 5G edge service metadata. And the prefix seed attribute TLV. Yeah. So in this, in some case, we made multiple sites connected to one edge or router through different interface. So we defined the prefix seed attribute TLV, and like this, it can define. We define the type names and the values. And the color attributes TLV, it's used to indicate the service level. Our solution supports two main deployment model defined by the CATs. In the CATs, they include the distributed, centralized, and hybrid. In the centralized model, the workflow is about we use the BGPS to collect all of the computing metrics, like the load and the capacity from the service site. And so the controller or the CPS is can implemented in the centralized controller elements. So the CPS computes the optimal path based on the combined network and compute metrics. And in the hybrid model, the workflow is the BGPS to collect the part of computing metrics service metadata, like the resource utilization. And also the CPS is used to compute optimal paths in the centralized manner, or we also can use the CPS to collect the community metrics and distribute it to the ingress CAS forwarder via a protocol like the BGP flow spec. And also we have a draft about to extend the BGP flow spec. So there is the workflow about the CAS deployment. So we think it's more. We believe this extension provides a necessary mechanism for the CAS framework. We sincerely welcome more comments and suggestions and contribution. And therefore, we would greatly to appreciate the work group consideration to adopt this draft. And thank you. Any question? Hello?
I was double muted, sorry. I see no questions in the queue. Please see the commentary in the chat about the charter for CAT's work. We still don't know exactly when IDR would be able to take up this sort of thing and exactly what that would look like. So please go ahead.
Okay, the chat. We should do the to answer the chat. The question about the chat.
There is text in the chat room. People, while you talk, look at the chat room. So if you click on your chat bulletin on the left side at the top, you can see the chat. We simply want you to look at the chat so you see Caton's comments about it.
Okay.
We will pause at another point and let you ask additional questions. I don't want you to have to hurry to read it. We'll go on to the next presentation, and then I'll pause at the end and you can ask questions of Caton. Okay? Does that work for you?
Okay, thank you. I will to sincerely back on the question.
Okay. I am going to start the next presentation. Our next presentation is from Yao on BGP, LP, IDR, BGPLS, SR policy supplement. Let me pull that up. Thank you for G for all this nicely laid out presentations. I'm going to pass the slide control to Yao. Please go ahead at your leisure.
Hi, I'm Yalo from ZT, and this draft supplements BGP REST distribution for SR policies and state as it has been presented last IETF. And here's a quick recap. So existing RFC supports collecting the configuration and state of the SR policy on the node and advertising it into BGP REST updates. Various TLVs are defined to enable the header to report the information at different levels, at the candidate path level, at the segment list level, and then at the segment level. And but we think that a few segment list related information is not yet included. The first is whether the segment list is in an administrative state. So it is in the network. It is not rare that the segment list is set by an administrator for different purpose. And the second is so the second information is the 32-bit MPLS RFC information is non-zero TC and TTL fields. And this is mainly because that the MPLS network actions for the so-called MNA substack solution repurpose the TC and TTL fields to carry additional information. MNA such as NRP and IOM can be inserted into the sublist in the format of FSBs, and the contents of the RFCs inserted into the sublist may be required by the controller when the header reports the state of SR policy via BGP REST. And here is some more information about MPLS RFC in the sublist. And the RFC 9857 already supports carrying in general any MPLS label in the BGP REST by using the segment type A. But it is specified in the RFC that the TCS and TTL must be set to 0 and must be ignored by a receiver. However, MNA defines different LSD formats as shown below. So for the LS, we can see that for LSD formats B, C, and D, their TC and TTL are repurposed to carry additional valid information. About the BGP-OS extensions. So a new flag in SR segment list TLV. So the S flag indicates the segment list is in an shut state when set. And there used to be a B flag we defined in the previous version, which indicates that the segment list is a pure backup path. But it is removed in this version, and the reason I explain in the next slide. And another extension in the draft is a new MPLS LSC sub-TLVs for SR segmentless TLV. It carries one or more generic 32-bit MPLS LSCs. And about the S flag, recently I just realized that there's another draft define similar flag for the same purpose to indicate the mixed state of the seed list. And about the history of the draft, it was submitted about 2 years ago, about 3 years ago, and version 3 was presented in last IETF, and with the MPLS LSC sub-TLV added. And there are some discussion around the relationship between the backup list and the reverse parse. And version 5 removes the B flag, considering that the PC multi-parse, the backup, the concept of backup segments was first introduced in the draft PC multi-parse draft, but it has clearly claimed that the backup list is not part of the SR policy architecture, so we remove the B flag accordingly. So I think that's all, and welcome feedback and comments. Thank you.
Any questions? G?
Yeah, I saw in one previous page, it shows M&A, the new label stack format defining for M&A. I also considered segment. I'm not sure whether they are segments for the SR in the SR architecture, or they are some kind of metadata, or whether it fits in the SR architecture or not. It's not clear to me.
So from my reading of as I think I in this slide, from my reading of IFC 9256, so the SR policy architecture in the SR policy in the SR list there are several types of segment types. There are several types of segment. So for segment type A, so the RFC describes that besides MPS label, it may carry some some generic MPS label. For example, the special purpose label or some transport label, if I remember it correctly. So I think that carrying generic MPS label in the set list is in the scope of the SR policy architecture.
Because the RC 9256 was published before M&A work. I'm not sure whether the M&A label stack entry can be considered as a general MPS label, or because they may require several label stack entries to be considered as a whole piece in the label stack, right? So maybe that needs some further consideration.
Yes, it's not like normal MPS label. Yeah, I'll consider more about that. So how to make it?
You might
How to
wanna
describe
you
it?
might wanna query Spring if there's a question on 9256 as to what can be carried. And Joel is here. Joel, can we put you on the spot to see if this question has been answered?
I'm happy to help. My guess is it hasn't been answered, but if Yaoli wants to send me an email with the question in a little longer detail than on this slide and a pointer to the draft, I will be happy to go look at the draft and figure out if I know of any discussions that are relevant.
Sure. I'll send you
Thank
a
you.
mail. Thank you for help.
Thank you. Then we'll ask you to come back and tell us, as IDR chairs and IDR, exactly what the result is. Would that be okay?
Absolutely fair. Thank you.
Thank you very much. Any other questions for Yao? Okay, we will go to our next presenter. Tyan, if I pronounced it, I will set up your slides.
Well, hi, Chair. Hi, Chair. My colleague, Jing Zhao, will introduce the slide for us.
Okay, I have passed you the slide control, so you may handle the slides. Should the slide control go to Ying Zhao?
Well, I can't control the desk. Can you hear me?
You can't control it?
Sorry.
You should be able to advance the slides. See if you can advance the slides.
I think I can control the slides.
Yes.
So can you transfer?
I have transferred it
to
to you.
her?
Try advancing the slides. Okay.
Oh, sorry,
Not
I can't.
Not working. Let me give it to Ying and see if it works for him. Or let me pass the control to Zing. There.
Okay, I can control the desk. Thank you, Chair.
Thank you. Please go ahead with your presentation.
Okay. Hi everyone. I'm Jing Zhao from China Unicom. Today I will introduce the draft advertisement of melt-sourced cell rules using BGP link state. First, I'd like to mention that the draft has already been represented about the requirements in cell working group. And first, let's talk about the melt-sourced cell rules and the management challenges they bring. Cell rules can come from sources, static configuration management tools, or different routing protocols like OSPF version 2 and version 3. It is BGP or their extensions. But melt-sourced cell rules make network management complicated. They are often rules conflicts and the rules are highly dynamic. So we have three typical uses to show these problems. Let me use case 1 as an example.
Case 1 is a conflict between IBGP and a management tool. IBGP requires blocking P1 at Internet interfaces, while the management tool permits P1 at the same interfaces because P1 is an unicast IP. This leaves us with a question: should P1 be denied or permitted? To address these problems, cell rules can cell rules can be advertised to a network controller, which makes monitoring and management much easier. For a rule advertising practical, we have three core requirements. It must be simple with a unified API for multi-source cell rules. It must be extensible to easily support more rule sources, and it must be efficient to collect highly dynamic rules effectively. BGP as defined in IFC 9552 is an extension of BGP used to collect network topology state information for controllers. It's already simple and efficient for topology collection. So our draft leverages BGP's advantages and shows extending it to let routers advertise cell rules information to a centralized server. This extension enables the controller to collect, monitor, and manage multi-source cell rules in the centralized way. Next, let's look at how to carry cell rules information in BGP-LS and the key information that need to be transmitted. The core information includes the rule source, which practical generates the cell rules, the node, which router mentions the rules, the interfaces, where is cell enabled, the source prefixes, the prefixes in the prefix list of specified interfaces, and the validation mode, block list or allow list. So the interfaces, source prefixes, and validation mode together form the complete source rules. We summarize all this information in the BGP as cell rule NLRI for transformation. So now let's deliver the details of the BGP LS cell rule NLRI. It has four key components, including practical ID, identify the local node descriptor TLV, the cell rule descriptor TLVs, and the cell rule descriptors TLVs include three main types. First, the interface name TLV. It identifies a valid interface for the source prefixes in the cell prefix TLV, has a variable length, and there can be 0, 1, or more of these TLVs. The second is interface group on TLV. It identifies a group of valid interfaces, and also 0, 1, or more are allowed. The third is the cell prefix TLV. It carries a single IPv4 and IPv6 prefix in the formats of prefix length plus IP prefix. And there must be at least one of these TLVs in the descriptor. And in addition to the NLRI, we define a BGP as attribute for cell mode and cell actions. The cell mode attribute is an optional, non-transitive BGP attribute that carries validation mode information. This is based on the document the IETF Cellnet General Cell Capabilities. There are four cell modes identified by the M flag. They are there for IBA cell, the interface BC, the prefix low list. There are one for IBB cell, interface BC, the prefix block list. And the 10 for PBA cell prefix species interface allure list, and the 11 for PBB cell prefix species interface block list. So for cell actions, we adopt the traffic filtering actions defined in RFC 8955 and 8956. Note that a single cell may merge melt source melt actions, and conflicts may exist between these actions. And the next page explains each of 4 validation modes with simple examples. And finally, let's go through the step-by-step procedure for cell rule advertisement. The first step is router running cell mechanisms generate melt source cell rules from static configuration management tools, OSP, AZs, BGP, and other sources. The second step is these routers establish BGP-LF seasons with the network controller. The third step is the routers generate BGP-LS advertisement for cell rule NLIs. We use separate IPv4 and IPv6 cell rules NLRIs for IPv4 and IPv6 prefix respectively. The fourth step is the routers report cell rules to the controller through these NLIs. The controller then collect, mount, and manage all melt source cell rules, which facilitate the centralized management and conflict detection and resolution. A keynote here, cell rules only exist on access or boundary routers that run cell mechanisms or protocols, and on the network controller. No other network nodes store these cell rules. Well, that this is the main content of our draft. More comment and discussion welcome. Thank you.
Any comments on the draft? We'll give you folks a few minutes to think about it and discuss. While we do that, I'm going to mention that we're going to take a short break from our agenda. Srihari has been called away shortly for a emergency meeting, so we're going to take his next presentation next. We want you to listen to it as he's asking for working group approval of his adoption. Any other comments for our current presentation? Seeing none, I will take back slide control, and Shri, I will have you set up in just a minute.
Sure. Thank you so much, Sue, for helping put me on the agenda earlier. So thank you. Really appreciate it.
You have the control.
All right. Thank you so much. Hello, folks. My name is Srihari Songli. I'm from HPE. I'm here to present a short update on the BGP dynamic capability, specifically what I'm asking the IDR chairs and the work group for us to move forward on this. And this is a quick agenda. I'm going to give a quick recap, talk about the current issue, and then talk about what the next steps can be. So just as a 1-minute recap, this is about capability negotiating during the lifetime of a session without resetting the session. We call it as dynamic capability revision. It is all about handshaking between the two neighbors. Specifically, the remote speaker will say what all capabilities it is willing to support a revision. Based on that, local speaker will initiate a revision of the capability. And upon the acknowledgement from the remote speaker, the local speaker will implement the new revision. And we've talked about this. I've presented this in the last couple IETF sessions. We've seen with the addition of a few structures and some procedures, this is compatible with the existing deployed base, whatever that is deployed so far. Now, the issue that I want to highlight here is the draft, the 16 version that has been around for quite a number of years, talked about these 3 code points. It introduced a dynamic capability 67, code point 67 for the capability itself. That has been put in the registry for capabilities, that's there. Then code point 6 for the dynamic capability message. As we know, this introduces a message. So there's a code point 6 for that the document proposes. Code point 7 that it uses, that it says for BGP notification error. And then it also says some notification subcodes for various errors that is seen to handle during the capability revision. Unfortunately, the protocol registry does not reflect the code point 6 for the message, code point 7 for the notification error, and also the subcodes. And the code point 7 is actually allocated for something else. So we are squatting on this code point 7. So what I'm requesting is in the latest draft, that's version 18, we have updated to say we've removed the code point 7 from the notification section and instead updated the INA section where we are requesting code point 6 for the dynamic capability message that we need to introduce, and a new code point to be allocated for the BGP notification error. So with this, what I would like is feedback from the chairs and the work group, and then also to requesting INR to update based on how this goes through. And once this is done, hopefully we'll get the current deployment, update these code points, and then get it corrected. That's all I have.
There's a few questions that we will ask on the list, but I might as well ask them here as well. I take it there are multiple implementations of this. Can you mention those implementations or not?
I do not have a confirmed implementation because I did not send any request for implementation report from. But what I know is there is a version from Cisco NXOS that has some implementation, and I believe Nokia also has implemented this. But maybe there may be others that I'm not aware of. But I was thinking of asking for a implementation report from on the alias to get the report, if that helps.
That would help a great deal. One thing that the early allocation is it stable enough to start doing this testing? So if you would check your co-authors and respond to the list about that. And again, that's Nokia, HP, and Cisco. If you know of someone else, I'll also ask the list, but that's part of the early adoption questions. So any questions for Sri right now? I will start this working group last call after this meeting, but I thought since we were coming up on the meeting, it might as well be good. So I'll give people a moment to jump in the queue because after this, Srihari will wander off to his urgent meeting.
Yes.
Robert asked something. It's a Ketan, it is a working group poll for early allocation, not a working group last call, but it's helpful to know where we are in the testing cycle. I do that even at early allocation if I think it's working. Good question, Ketan. Anything else? Okay, well, thanks Srihari for this, and I will wander off to the next presentation, which will be mine for introducing FlowSpec.
Right. And thank you once again for reshuffling the agenda to help me for this. Thank you so much.
You're welcome. Just a minute, I'm having trouble finding my slides. It may be my fault again. Gee, I'm looking for BGP information for flow spec. Maybe it went. Okay, I will take me a moment. Jeff, if you will take control, I'm going to load the slides. Thank you.
Certainly. So you're looking for me to load the next set of slides for FlowSpec?
These are the FlowSpec, my intro slides. Did you get them? Otherwise, I'm going to load them.
I do not have them saved locally.
Okay, I have them saved locally as I wrote them. I thought I sent things off to G last night, but it was in the middle of the night, so next time do your slides earlier is the rule. Okay, thank you. I've uploaded the slides. Now let's see if I can share them. There we go. Okay, and Jeff, stay around. This one you may want to kibitz on. Okay, we're about to start in on several presentations regarding for flow spec. That deserves a little bit of an explanation because we have been tracking flow spec but haven't made much progress. As we've mentioned previously, I had a lengthy outage, and Jeff and I were in the middle, at a lengthy personal time off last year. So some of this flow spec, we need to explain where we are and how we're working toward adoption. Again, we are tracking the flow specs in two places, the wiki and the GitHub. We are transitioning more toward GitHub as we're working on using it as a daily interaction for slides for our status. You will also hopefully with it before the deadline for this week, I hope by this week to have Shepherd reports out for all the flow spec drafts. The purpose of these Shepherd reports is to give you clues on what to modify before you go to the next step. So where's our steps? Right now we've sent out flow spec v1 actions and a draft. We've sent out draft IP, draft IETF IDR flow spec redirect IP, and we'll set out a second one today. Those are to get things that were at the ISG and they were sent back. So we're treating those as things which we promised to do for the ISG. We will send the two drafts together. Then we have to talk about some things about the direction for FlowSpec v1 and FlowSpec v2 actions, whether it's in extended community or wide communities. Notice we have the wide community information as Jeff has that on his to-do list. Then we reclassify some action drafts as FlowSpec 1 or FlowSpec v2. Then we'll start adoption call for drafts based on IDF, IDR, FlowSpec v2 IP basic, and do an adoption call for HARES, IDR, FlowSpec v2 more IP filters. Then in a 6A and 6B, we'll do working group last call for draft IETF, IDR, FlowSpec SRv6, and adoptions for anything that simply relates to filters. We will then do more action calls once we get the IP more action sorted out. I know that's a long cycle, but we found, as Jeff and I both chairs and authors, that the action drafts needed a little work, and better to fix it now. So what are we seeing today? Today we have a few filters based on draft HARES, IDR, FlowSpec v2 or IP filters. We have the one that we saw wonderfully in the last ITF with 2 implementations and lots of detail, draft CUDI IDR content filter FlowSpec 03. We also have an update on the BuiltWise filters. Remember, for filters, these are tools in the toolbox. They may be helpful. They may be something you leave out. Then there are 3 other ones sitting out in the wings based on scheduling, AS filter, and some CATS things. I realize CATS is still sending us the requirements. Then we have more actions. This one comes from draft CUDI IDR FlowSpec feedback binding. How to have it. This is its first flow talk. We expect that the CATS flow specs and other generic grouping flow specs will come from that. Okay, let's look at how these things fit together. Draft CUDI IDR FlowSpec feedback binding is connecting the telemetry information to the FlowSpec to filter. It's an action in an extended community. That's why we have to consider whether we have how it's working with FlowSpec v1 versus v2. FlowSpec v1 actions, it is the responsibility of the implementer to figure out. That's not a really great way to do it, so we're hoping in FlowSpec v2 to have some rules, hence our need to look at the action rules between FlowSpec v1 and v2. This is an interesting addition to fix an actual problem, and that draft CUDI IDR content filter FlowSpec showed was very helpful as content filter. That does filtering. In contrast, K2 bitwise IP filters provides better load balance in the network. We find that that's a really good thing. So, and then there is some FlowSpec based on the meta service data. We will start with the meta service data, and I will go on from there. Is there any questions before I go to the next presenter? The next presenter is Xin Yi. And I apologize for having problems. I will start with the presentation.
Okay.
Please, I will hand you the slides and we will control.
Sorry, that's the wrong slide.
That's the wrong slide set. My apology. Thank you. Let me grab the slide set back and get the right slide set. Thank you very much.
Okay.
There, I've got it. Thank you for your patience.
Okay, it's right.
Thank you very much. And pronounce your name for me one more time. Jeff did a great job and I did a terrible job. So would you introduce your name again?
Xin Xin.
Xing Xing. Thank you very much.
Thank you very much. Okay, I will presenting the description of the service metadata in BGP flow stack, and this draft is also come from the CATS requirement. We talked earlier. We talked about how BGPL's extension to collect service metadata. It's from the edge side northbound to controllers. And now I will to focus on the BGP flow spec and which handles the southbound distribution of the processed metadata to ingress routers to making compute a well traffic steering wheel. So it's to meet the CATS framework about the hybrid model. In this model, part of computing metrics are distributed among involved network devices, and others may be collected by the centralized control element. So the controller should to display the computing metrics to ingress CATS forwarders. So we think we can to do the BGP flow spec to do this work. And while we use the BGP flow spec, we think the BGP flow spec is weakly controlling, and it frames but does not override routing. And so we think the BGP flow spec can to distribute the computing metrics, and also the aggregated metric TLV is added to the BGP flow spec to distribute the metadata, and this can reduce the update frequency and the network overhead. And also the controllers use the BGP flow spec to push the metadata and the steering policy to the ingress routers, which then direct traffic based on the compute well decisions. So we think the BGP flow spec can use to do the distribution. Sorry for the slide and the force. Yes. About the information forms, we think to recommend the use the aggregated values distributed well BGP flow spec about this. And in this draft, we designed two models about the key TLVs. The first is the metadata path attribute TLV. This can reuse the 5G edge service metadata. And the other is the aggregated metric path attribute TLV, like the slide to show that. And this is the it delivers the level 2 normalized metrics in the CATS matrix defines, and so it can like a single score for the site overall health, and it's about the type, length, and the value. And when we use the BGP flow spec to do the CATS, and we can do the workflow like that. The first, the BGP-Else is used to collect a part of computing metrics, and maybe the controller is to use the compute optimal path in the centralized manner, or the controller can collect the computing metrics and distribute it to the ingress CATS forwarder via the BGP flow spec protocol. And so the ingress CATS forwarder may also have some local computation capability for the subsequent packets access the same servers. so the ingress routers can do the compute optimal path. This is the hybrid model workflow. So we choose the BGP flow spec because there is a leverage existing BGP extension, reduce deployment effort, and also we only do the minor network changes, and also centralized processing, reduce network flooding and handling large scale. This is the same the BGP else draft, and we sincerely welcome any question, and we want to do the adoption call, and thank you. Any question?
Hi, Xinjin. Thank you for your presentation. So I understand your motivations to want to use FlowSpec, but I think there may be some things to work through on top of the CATS charter considerations about using FlowSpec as one of your mechanisms. As you put in your very first slide, you had called this sort of weakly interacting. One of the things that we are working through as part of FlowSpec version 1 and version 2 is how the forwarding pipeline is influenced, when we have many types of rules that can interact. Have you spent any time analyzing how this feature should interact with other FlowSpec features? And you are no longer sharing your microphone. There we go.
Okay. Sorry. Maybe we need to do that work. Your question is to how do
they interact?
Okay, interact others.
So the usual example is that FlowSpec is normally treated as a firewall, and the firewall itself has rule orderings. Most of the features that we'll be seeing later today are discussions about how firewalling and packet matching and packet forwarding is changed. CATS programming is mostly about changing and taking action on the forwarding. So the discussion about how that interacts with other pieces of FlowSpec would be useful.
Maybe we want to use the BGP FlowSpec to send the computing metrics, not to do to do others. And we also just to distribute the computing metrics.
So if your goal is not to have this added to the FlowSpec forwarding chain, but you just want to use the packet formats, maybe the better answer is to make a different protocol using some of the FlowSpec encodings. I can take my comments to the mailing list as well.
Okay, thank you.
It might be useful. Note that PCE has grabbed encodings from various things in IDR and used it in a different protocol. It's perfectly fine to say I like this encodings, but the protocol distribution mechanism is not the same. We don't want you to invent something new if it's helpful someplace else. But Jeff will go through this on the list, and I'm sure Jeff and I would be glad to have a email conversation or a Zoom call with you to talk more about this. Okay?
Okay.
Is there any other comments from people? Otherwise, I will go on to the next present. We really appreciate you being here and getting the feedback. That helps us sync up and your presentation was well done so that we know what the problems are. We appreciate your coming and presenting. Thank you.
Thank you. Thank you very much.
No, I don't have. I've got the wrong slide. Just a minute. Let me go back in again. Nope. Okay, just a minute. There it is. Thank you. I'm sorry.
It's fine. Thank you.
I have the right one. You now have slide control.
Yeah, I can control the slides. And this presentation is about our latest work on flow spec extension for feedback banding. And this time I will focus on the problem statement, the overall framework, and the key design updates. As we know, flow spec is widely deployed for traffic handling and DDoS mitigation, but it fundamentally provides one-way control. Successful rule propagation in the control plane does not simply effective enforcement in the network. This limitation is particularly critical in the data plane, where actual forwarding and traffic handling decisions are made. Once a flow spec rule is installed, the controller has no standard visibility into whether and how it is actually enforced. In carrier networks, flow spec rules may become ineffective due to policy conflicts, installation failures, or simple because no traffic matches the rule. More importantly, this situation may persist without timely resolution since the controller is not aware of the real execution status. As a result, operators lack execution feedback, making it difficult to understand real enforcement behavior and continuously optimize traffic handling strategy. This gap between control plane intent and data plane behavior is the core problem we are trying to address. Here is the overall feedback framework design across the intent, control, and data planes. As the core is the control plane, where flow spec rules are generated and their execution status tracked using a state machine. The key contribution of this draft is the flow spec feedback action, which binds rules to feedback identifiers and request execution feedback from the network. In the data plane, rules are enforced and statistical information is collected during packet processing. BMP extensions report control plane execution results, such as rule installation status, while telemetry statistics provides data plane visibility. Together, these components close the loop between policy intent and enforcement. In this framework, this draft only focuses on the feedback action, including the state machine definition and field design. BMP and telemetry or other protocol are treated as supporting mechanism defined in other drafts. These slides introduce the flow spec policy state machine, which provides a unified view of rule execution. A flow spec rule starts in idle, then moves to received once the rule is received via BGP update. After validation and installation, it enters in active, meaning the rule existed in the device but has not matched any traffic. When traffic is matched, the rule becomes active and its execution effect is then evaluated as effective or ineffective. This state machine makes rule execution explicit and observable instead of assuming delivery means the rule actually works. This slide shows the encoding of the flow spec feedback action. Based on the comments from the last meeting, the feedback action is now encoded using a community container rather than a fixed extended community. This change removes strict length constraints and provides better extensibility for future evolution while keeping the current design simple and minimal. The figure illustrates the current field's layout. We believe the design can involve future, and we welcome additional suggestions from the working group. For next step, we plan to update the draft based on the comments received and will continue the discussion at IETF 125. That's all. Thank you.
Do we have any questions? Jeff, do you want to make any comments on community container for this one?
No comments from me right now.
Okay. Yusha, that was a great presentation. I believe you have the next presentation as well. I will start you up.
Okay. Okay, I will start the second presentation. It's about the packet content filter for BGP flow spec. Can we start now?
You should be able to control the slides. Can you do that?
Yeah, I can control it.
Good, thank you.
Okay, so the topic is the packet content filter, and we can also call it payload filter, and it's a part of flow spec v2. At this time, I will particularly focus on some considerations and hardware deployment rather than protocol encoding details. This work is motivated by the increasing intensity and complex real-world DDoS attacks. Recent attacks have reached peak traffic volumes far beyond the capability of traditional scrubbing centers, and many attacks exhibit fixed or characteristics payload patterns, such as ACK flood or SSDP amplification traffic. These observations motivate the need for a new type of flowback filter that can match on packet content rather than only on header fields. The filter allows matching on specific payload characteristics using parameters such as content length, offset, and content value. To control evaluation cost, we define a rule ordering mechanism, which user-defined ordering is respected first, and otherwise a default ordering is applied to limit the scope of packet inspection. I will not go into encoding details here and instead focus on how this filter can be safely and particularly deployment. This slide summarized the key considerations behind the payload filter design, focusing on operational security and scalability. For an operational perspective, payload filtering is intentionally designed as an optional capability rather than something that should be enabled everywhere by default. We believe it is more suitable for controlled locations, such as edge node, scrubbing centers, or firewall-like devices, and not recommended for deployment on backbone core routers. Different devices may have different capabilities in terms of content parsing and rule scale. Therefore, the design avoids a one-size-fits-all assumption and allows operator to enable payload filtering selectively based on device capabilities. To avoid confusion in payload offsets, especially when kernel or MPLS are used, we recommend matching on the inner IP packets instead of the outer headers. From a security perspective, payload filter is a powerful mechanism and should be tightly controlled. Payload rules should be accepted only from trusted peers, and in inter-domain scenarios, we should not assume that all domains have consistent payload parsing or execution behavior. As a result, payload filter is better treated as an intra-domain or tightly controlled enhancement, which reduce both security and interoperability risks. In addition, payload filter are expected to be combined with other flowback match conditions, such as prefix or protocol fields, to reduce false positives. Implementations should also avoid triggering BGP notification due to parsing errors and should apply update rate limiting and anomaly detection to protect control plane stability. Finally, from a scalability perspective, payload filter is not intended for large-scale deployment. We recommend limiting it to a small set of high-level rules, using flowback V2 ordering rules to restrict the amount of traffic that requires payload inspection and carefully controlling propagation scope to avoid inter-domain scaling issues. Okay. Okay, to further demonstrate the effectiveness of the payload filter, we validated it on real hardware device. Our evaluation was conducted on a signal switch with ASIC-based switching chips in a testbed environment. Flowspec rules are translated into hardware ACL entries, and payload matching is implemented using user-defined fields with TCAM, enabling direct matching on payload bytes at line rates. Device output confirm correct rule installation and traffic statistics show that targeted packets are effectively dropped, demonstrating both correctness and performance. This deployment showed that payload filter can be implemented using existing programmable hardware without changes the forwarding architecture. For next step, we welcome any question and comments from the working group, and we plan to continue updating the draft, focus on optimizing the field structure, and would like to move toward to an adoption call when the working group ready. That's all. Thank you.
Thank you. That was an excellent presentation, Yusha. And do we have any comments? Jeff, did you want to add comments?
I did want to ask a question. So, Yuja, for your implementation, are you using the current format of FlowSpec v2?
Yes, it is in the FlowSpec v2.
Okay. Did you find the format easy to use for your use case, or did you have comments that we should take into account for changing FlowSpec version 2 encoding?
Sorry, can you ask again? I don't understand.
How easy was FlowSpec version 2 format to use for this? Easy? Hard?
It's easy to use, but for some complex scenarios, maybe it needs to update.
Okay. Thank you. I'll send further comments on the mail list.
Thank you, Jeff.
Thank you so much for the good presentation, Yusha.
Thank you.
Any other comments for Yusha? I'm amazed at your work. That's quite a lot to have it all looked at, examined, and then run through some hardware forwarding. Okay, Nat, it's next up for you. So I'm going to start your presentation.
All right.
And you have try to give the things that are the updates. Let me stop sharing the slides. Okay, you should have control.
Okay, I have control.
I just need to mention one thing. We have one other presenter after NAP. We will go to VGP SR and SRTE, and it'll be Swadesh. So that'll be about 10 minutes after 12. This meeting goes to 12:30, but we were gonna try to finish by 12. I think it'll be 12:10. It's good to have discussion. Thank you. Go ahead, Nat.
Okay, so hello everyone. I am Nat Gao, and today I'm presenting the Bitwise IP filters for BGP FlowSpec on behalf of all my co-authors. So basically, we're trying to explain what we're trying to solve and describe the encodings of those components and some deployment guidelines and next steps about this draft. Okay, so what we're trying to solve, basically, let's refer to this figure. On the left-hand side are the subscribers, residential or mobile subscribers, and on the right-hand side are basically it is the internet. And for some services, for example, the firewall or the DPI services, the needs symmetric flow. Basically, when the traffic from the same subscriber must go through the same service instance, and the traffic on the other direction must go through the very same service instance, so that service will function correctly. And in most cases, the service instance cannot handle all traffic alone. So we may need to load balance the traffic based on the subscribers' addresses across multiple service instances symmetrically. And so that's what we're trying to solve. And there are some assumptions about the subscribers' behavior, because the assumption is that if you have so many subscribers, and then you can basically assume that the subscriber behavior will be almost the same according to the least significant log n bits, if you want to split them into n parts. Basically, the subscribers' behavior will be almost the same across those different groups of the least significant log n bits. So that's the assumption of the traffic. And so here are the rules illustrated to load balance the traffic. Basically, we have router X and router Y. Router X is subscriber facing routers. So basically, we match against the source address of the least significant 2 bits. Okay, and load balance them into different service instances. And on the other hand, router Y is facing the internet. So basically, we match against the traffic that goes back, which is the destination address refers to a specific subscriber. So that's why the rules are matching. So that's a simple solution for the load balancing behavior. They may not be very uniform, but it's in most cases for a large subscriber base, it will work in most cases. And the encodings are very straightforward. Basically, we have a value that has 2 tuple, the prefix and the mask. And the mask indicates the positions to match, and the prefix is the value to match. And we only match against the positions that is 1, indicated in the mask. And these 2 subTLVs, basically, we can have multiple occurrences in the same NORI. And those subTLVs forms a logical OR. Okay, so thanks for Robert for suggesting the deployment guidelines. So basically, the guidelines are basically, although we have this bitwise filter and the legacy filter, but we don't recommend to use them, both of them at the same time. Use either of them, don't use both. And also, when deployed with the redirection actions, such as the example we have described, these flowback rules are actually PBR rules. So forwarding loops might happen just as traditional PBR rules. So caution is needed for that. And also, when we have ECMPs to the redirection destination, the matching packets are still subject to the hash-based load balancing towards that destination, for example, service 0. Okay, so basically this forms a hierarchical load balancing scheme. With the first stage is load balance based on the subscriber's address, which is controlled by the matching filter, bitwise matching filters. And the second stage is based on the traditional hash-based solution that is load balanced across all ECMPs to that service instance. However, they are still the traffic is still going to the same service instance. So that's it. And also the bitwise matching filters, the performance of these filters might vary from the legacy filters. So it is recommended to test the hardware before you deploy these build-wise filters. And that's the deployment guidelines. And the next steps are basically we would like to find the implementers interested in implementing this. And also we're calling for co-authors. And for maybe there are some potential users, they have other use cases. Maybe we can integrate that into the draft. Also, any suggestions are welcome. Yeah, so that's all. Thank you.
Thanks, Nat. My question's very straightforward, very similar to the question about the CATS use case. Since these things will be interacting, how do you think this will be working with multiple types of rules? So the one that comes easily to mind is a redirection being used for this load balancing, plus potentially a second redirection for some other purpose.
Maybe basically the first thing I would think, yeah, maybe we can discuss on the list further. Okay. Because there's I don't have that in mind right now. Sorry.
That's okay. And this is a conversation, and a promise that I am not picking on any specific person giving presentations today. Most of our design challenges that we have for FlowSpec version 2 is not how do we make a extensible PDU that can carry some use case. We're seeing a lot of creativity from the working group. This is a good example of that in this presentation. But we are primarily figuring out how do we make all these different rule types capable of interacting with each other, and when they cannot interact safely, what mechanism should we be using to detect that and to provide a clear order of operations? So thanks. We'll take it to the list.
Okay, thank you.
Is there any other comments? Otherwise, we'll go to our last presentation. I also have a status presentation, but we're running long, so I will show that last as we are going to start working group last calls for some of the BGPSRs. Let me grab back the control and start the next presentation. Swadesh, it will be yours. There we go. There.
Thanks, Sue.
And Caton calls this BGPSR because it deals with the BGP attribute for prefix SID. Go ahead. You have control. Well, you will momentarily. You should have control.
Sure, sir. Thank you. Hey, everyone. I'm Swadesh Agarwal, working for Cisco Systems. I will present this draft on behalf of my co-authors, and this draft at the high level provides the ability to advertise SRv6 SIDs with the BGP LU SAFI that carries the infrastructure prefixes like loopback addresses in the interdomain routing. So I already presented this in IETF 124, and as per the chair's comment, I have added the error handling section. It's similar to RFC 9252 because encoding is very similar. Also, we have simplified the options. That is, we have removed the n.dpm behavior-based transport procedures, and this was done because DTM 46 and DTM fulfills all the requirements that was required to transport the BGP LU LSP across SRv6 domain, similar to MPLS over IP. We have also added a new co-author, Rajesh from Juniper. So the purpose, we already have a architecture document in the Spring for SRv6 and MPLS interworking, which provides the reference architecture in the multi-domain network where each domain runs SRv6 and MPLS data plane independently. The document defines new SRv6 behaviors such as DTM46 or DTM for the purpose of transport interworking. There's also a document in SRv6 ops for deployment guidance for such interworking. In this draft, we extend the BGP-LU SAFI, which means AFI 1 and 2 with the SAFI value 4 for advertising these new SRv6 SID behaviors in BGP. So in this document, we define a new TLV called SRv6 transport TLV of the BGP prefix SID attribute to announce the SRv6 SID with the BGP prefixes in the BGP-LU SAFI. The TLV is encoded exactly like SR6 service TLVs in the prefixed attributes already defined in RFC 9252. Currently, it is used to signal DTM46 and DTM behaviors for the interworking. And yeah. So I'll just go into general procedures. DTM46 and DTM behavior encapsulates the MPLS packet in the IPv6 header to transport the BGP-LU packets through the SRv6 domain. To accomplish it, we have to we advertise this ability in the BGP-LU SAFI, which advertise the PE address, and program that at border node that allocates the label as it does for any BGP LU prefix when it sets the next hop self as per the RFC 8277. Additionally, it allocates the SRv6 SID of n.dtm46 and n.dtm behavior and advertise that in the SRv6 transport TLV as a part of this draft. And it's advertised without any transposition and signaled with the BGP-LU route. Same SRv6 SID is signaled with the multiple BGP-LU routes by the domain border routers. The behavior signals and semantics, that means you have to push the ingress border router has to push existing BGP-LU label that is signaled in the NLRI. And additionally, it has to perform h.ncaps.m, where the DA would be the destination address of the IPv6 header would be SR6 SID signal in the SRv6 transport TLV. Such LSP and this LSP, because the LSP will exist between the provider edge routers, can carry any traditional services which it already provides, like global table traffic, VPN, or eVPN traffic. So it is just showing, in diagram how this works. You have three domains, MPLS at the edge and SRv6 in the middle, and you have services running between the edge devices E1 and E10. Here in the example, we are showing L3 VPN service with the VPN label advertised from E10 to E1 with the VPN label. So for E1 to resolve these services and send traffic through this multi-domain network, E1 will need the address of E10, which currently in such a deployments may be advertised in the BGP LU SAFI. And that's what we are showing, the advertisement of BGP E10 address from right to left, where in BGP LU SAFI with the prefix address, which is a loopback of 10 with the advertising towards the E1. At the ABR7, which is a border router between SRvs and MPLS domain, we advertise BGP LU prefix as it happens today, performing the next hop self and setting the next hop as a ABR. Additionally, if you see, we are advertising the SRv6 SID of DTM46 behavior with that advertisement to the ABR4. On ABR4, we will perform regular BGP LU action of swapping the label of BGP LU LSP, as well as we will perform h.ncaps with the SRv6 SID. And that will provide the transport through the SRv6 domain. So this has already been presented previously at the IETF as well as at the BES. And we are waiting for the code allocation for this TLV. And I would request for the adoption because it's It's a short draft with the simple enhancements, which provides the ability to advertise SR6 SID with the BGPLU SAFI. And we have a interest from the deployments as well as multiple implementations underway. Thank you. Thanks, Sue. Thanks, everyone.
You're looking for code adoption. Adoption of the draft followed by code allocation. Did I get that right? You have multiple implementations, Swadesh, coming. You're looking
Yes.
for code out. You're looking for us to do a
Yeah, we will need a
adoption.
code allocation. Yes.
You'll get the same question.
I'm not sure. There's some lag, Sue, but yeah, yes, we are looking for both for the code allocation for implementations to move forward as well as adoption of this work, because the simple work to
go forward. Yes. Okay. So I will add it to. It's on the adoption queue. I will indicate that it has deployment starting. One question we'll ask on the list for early allocation is for if you can give at least one other example of someone you're working with interoperability with. But please let me know if you can say that at this point. You don't have to say it now, but that will be part of the code allocation question. Okay?
Sure. So yeah, I'm aware, so we can provide that information. Sure. Yeah.
Thanks. Anything else? Okay. For some of the other adoptions, with your kind permission, I'm going to share slides on the BGP SR calls that we're about to do. Give me a moment. And I put myself last. Let me pull back the slides and share another set of slides. Okay. Many people asked us, what are we doing when we're reviewing the slides for BGP SRTE? That's the SR policy, or the BGP SR, that's the BGP prefix SID attribute. So again, see the same places I've been pointing toward. The status GitHub is updated daily, IDWiki monthly. So let's look at what happens. We have the tunnel in caps and current work. Current work is both a whole bunch of drafts with SR policy star, SD-WAN, multicast controller, Geneve, and then we have a bunch of Arista specifics that are allocated by Anna, but I can't find the specs to keep them in link. So if you look at this, one of the things that is unclear by many of the drafts is which NLRI it works on and what sub-TLVs. So part of the BGP template / checklist is to make sure we have that. Some things like the request of a segment list for a tunnel and cap TLV is a bad choice, like that comes from the multicast controller. Not a good name. That'll delay you. Here are the things that are looked at for the SR policy, and then there are sub TLVs. So let's look at it in the wonderful picture. Here's what we have, and I encourage you to look at it for the drafts that are currently approved, and the yellows are coming up with working group last. For example, we have both NRP, which is approved for publication, and then we have explicit null label segment at the TLV level. Under the segment list, we have segment list identifier coming for the draft IETF IDR SR policy sedge list ID. And we have other drafts which deal with metric, path segment identification, path MTU, and an ELP explicit null pointer and a reverse path segment. Those are adopted. We then have a whole bunch at the TLV level that are being requested to be adopted. Head-end behavior, L2 head-end behavior, validity check on the policy template ID on the policy time element policy. And then we have at the TLV level constituent SR policy with its sublevels. More of what you're seeing is segment additions, policy that link flags. So please be aware that as we call, we're asking inside of the chairs, and we'll ask on list, do all the identifiers really help? How many of the metrics are really useful? These are questions we ask within the chairs, and we'll bring them up to the list. Do any of the head and actions interact or conflict? Is there a problem with optimization? Draft loose segment list, I asked about optimization issues. Here is the request that Swadesh just gave us with the transport and the original RC. The chairs are trying to be very focused on your reviews. So please take this presentation and hopefully store it aside when I say, here's the shepherd and here's our chair feedback. With that, we're at the end of the session. I am going to stop sharing the slide and ask for any final comment. Okay, please give the chairs any feedback on interims. We're working with our AD, Keithan, and each other to try to be as effective as you can. If you ever look at how many drafts we're actually handling, there's an amazing amount of wonderful work from all of you. With that, any further comment from you, Jeff? Before we complete, or G?
Nope, I'm all set.
Okay, we will see you either in person or virtually at IETF 125. Thank you again to all the wonderful presenters. We really appreciate your feedback. Bye-bye.